Good day, folks. This is video number 11 in the playlist, which is devoted to motion design application in 3D experience. And the particular playlist is actually the kinematic one. There's two of them, the kinematic and dynamic, but this has to do with the kinematic playlist. Now, tutorials 11 and 12 are very close to each other, but there's a difference. In the tutorial 11, which is the current tutorial, I make all my engineering connections in the assembly design. Okay, I do not create any joints in the motion design application. What we have here is an axle. Let me go back here for a second. An axle, a frame, and that's what I call it, axle frame. And this axle, the wheel of the axle is supposed to roll along this path, okay? So what I'm going to do is to create a roll curve joint, a revolute joint, and because I don't want this frame, I don't want this frame to be flipping. I want it to stay horizontal. What I do need to make is, among other ways of doing the problem, is a planar joint between the top face of this frame and a particular plane that is at the same height made in this rectangular base. Okay, there are other ways of doing it. So what I'm saying here is that here I will make a planar joint between the top face and a plane that is at the same height as the top face of the frame. Okay. I've done this thing with the 3D mechanical systems design application in 3DEXPERIENCE, and there's a playlist for those tutorials. And I've also done it in CATIA V5 with different playlists. Okay. So let's go ahead and do this problem. Dimensions are not important, except for a couple of dimensions that I may be taking an eye on. Let's start with the assembly design, right? And I'm going to insert my first 3D part, and this is going to be the Earth. I'll call this thing the Earth. All right. And here is the instance name. Okay, let's go make it. I'm going to double click on this, on that plane. I will sketch. I'll sketch a rectangle, like that. Exit. And pad this thing. I'm going to go to part design. Okay, pad it. Oh, let me make this thing 10. Okay, very good. Like so. Let me actually pad it down. It really doesn't matter. There. On that face, I will sketch a path with a spline, perhaps. Now, when you look at tutorials 9 and 10, you'll see that I have created a plane here perpendicular to that path. And that is the reason I did that. I wanted to position the axis so it's tangent to that path. It's just that in the CATIA program, it had to be tangent, otherwise you cannot create a roll curve joint. But it looks like they have done things here in motion design so that, and in fact, when I do the engineering connection here, that it doesn't matter. It will actually bring it. When I say roll curve joint, so I try to do a roll curve joint, it'll bring it and just make it tangent. So though that step that I did in tutorials 9 and 10 are unnecessary here. Okay. Yeah, that takes care of this. And let me go and insert my wheel. Let me actually do the frame first. So go all the way to the top, insert 3D part, and I'm going to do the frame. Let me call this new frame. And frame. Okay. We'll make it. Double click on a convenient plane. For example, on that YZ plane, I will sketch. Okay, my frame is going to be just a rectangle. And because the shaft of the axle is going to go into it, so I'm going to draw a circle here. This is where the shaft of the wheel is going to go. Exit. And then pad it. Yeah, that's sure, that's good. There we are. And you're going to go all the way to the top. Right click, insert 3D part. I'm going to call this thing, properties. I'm going to call this thing axle. And axle. And let's make it. So it is convenient for me. I'm going to draw it on that face. I will sketch. Why do I project that circle? Instead of me drawing the circle and dimensioning it, project this. There we are. And I do the axis, yeah. So let me exit. Okay. And pad this thing. Yep. And then I draw the wheel. This is the shaft. You can see that. So on that face, I will sketch the actual wheel. And make sure it's a coincident or concentric. So that curve, that circle, control this circle. I want them to be concentric. So constraints defined outline boxes. Concentric, good. Exit. Exit. And add it. Oh, you know what? Let me go ahead and let me go to that sketch. Let me go to that sketch and draw a little indentation here, a little circle here, so that I can see that actually it is rolling later on. Exit. And then pad it. Let me do by 10. Actually, let me make it 5. Looks nice there. Okay, and I need it on this side. There are different ways of doing it. For example, I can say, sure, on that face, I will sketch, project that circle. Once again, project that circle, and then pad it by 5. Exit, and pad it in the other direction. Let me see now, which one did I pad? It's this one, right? Yeah, this one in the other direction by 5. Good. So you can see if I hide this thing, there is the axle and there is the frame. Good, good. All right. So we want to do a few things. First of all, let me bring this thing down and put it on that curve. Oh no, no. Let me bring it. Let me Well, just let me bring it down, put it on that surface. Well, first of all, we're done here as far as the parts go. All right. Now we go some. First of all, we fix the earth. That's the first one. That's going to be fixed. You see that? Then I'm going to create a revolute joint between the frame and the wheel, the axle. So let's see now. We have revolutes. I use this template. Not that it matters that much at all. This axis and the axis of the frame, and I need the side, for example, this side of the axle and this side of the frame. I don't need that stuff here. And then we say okay, and no. Okay, good. Now let me bring this thing and make a roll curve joint. Let's see if it works. So let's see what we got here. We have a revolute joint and a fixed part. And let's see if we can do a roll curve joint. Great. So we go here. Now, if you want to do a roll curve joint, you're not going to find it. You're not going to find it in this list. So you go, engineering connection, you select the roll curve joint. Roll curve joint. It says what rolls are what? Well, it's, let me move this thing out of the way. It's this circle that rolls on that circle. Now, notice what happened is that it works, except that I want this thing to be, on that face. So we say, okay. So what I'm going to do is go once again, you go here, engineering connection, and contact constraint between this face and that face, a new engineering connection, and then we say, okay. Okay, good. The only thing is that I don't need that contact, that user defined. I don't need it. So I'm going to either deactivate it or delete it, whichever you prefer. So I'm going to delete it. Good. The only reason that I did this is that didn't want this thing to be tilting on that plane. Now, just a point of comment, comment is that roll curve joints in CATIA v5 DMU, if they were not already tangent to each other, it will not work. But it looks like they've taken care of that in this application. All right. Now, in principle, if I made this thing move, it'll work, except that this frame will also flip with it. Okay. So what I'm going to do, I'm going to make a planar joint between that top face and a plane at the same height in the base. So how do I create a plane in the base of the same height? The easiest way is to go to the earth. I'm in the earth now, and I say make me a plane, and the plane that I want to make are, for example, through I don't know, maybe 3 points, through uh, 3 points. And what points? For example, this point of the frame, this point of the frame, and this point of the frame. It will create a plane for you at the same height right there. But this plane belongs to the base. Okay. So I go back to assembly design. And then we're going to go make a planar joint. You have to go to engineering connection, user define, planar, 2 planes. Doesn't matter whether this one, that one, makes no difference. So I select this plane and that plane. And then we say, okay. You will see that if I go to motion design and try to create a planar joint, it won't let me select that plane because it expects a feature on that plane, maybe a surface or something, a face, etc. But you can see that if I create my joints directly, it allows me not only to do the roll curve joint, but also the planar joint. Okay, well, let's update this thing. Very good. And now we're going to go to motion design. Motion design. Say okay. And first of all, it's going to create a step for me. That step's dynamic. I want it to be kinematic. I changed it, although it really doesn't matter. Now, look at the joints. All the joints were transferred here. What I'm telling you is that, first of all, if you are trying to do the roll curve joint, if you're trying to do the planar joint in motion design, it won't let it just pick those two, the plane and the top face. It expects the plane to have some face on it. And this is why tutorial 12 is important if you go that route. That's pretty much it. So, yep. Why don't we give this thing, obviously, well, let's check a couple of things out before I do that. Kinematics player, and there is the roll curve. You see this roll curve? See? The other one is for tilting. The other one is actually, where's the other one? Oh yeah, this is also roll curve. Yeah, the same thing. Yeah, that one, because I have a planar joint, it doesn't work. Yeah, good. Cancel. Now, now we're going to create a driver on that revolute joint. Click on this, create a new function. It's a constant. Give it the speed. This angular speed. Let's make it, I don't know, maybe 1 rad per second. And then we say okay. Let's say okay. And now we're going to run it. Simulation. Run. Wait until it finishes. And then we select the result. There's going to be physics now because I applied the angular velocity of that revolute joint. There's going to be physics. So let's do animation. 5 seconds. Whoops, going in the wrong direction. Okay, so no problem. Cancel that. Go back to the driver. And put a minus instead of 1. We'll make it go in the other direction. Okay, that's good. And we have to run it. By the way, let me change the duration to 10 seconds, maybe 8 seconds longer. Simulation, run, wait until it finishes. It finish, and select the result. Go to results and animation, and play it. There's physics here, okay? You can, because I put the velocity in there, you can, for example, calculate the velocity of a point and acceleration of the point, etc. It's not just a cartoon. So, if you want to play back and forth, let me do this thing again. Yeah. So what I'm going to do in tutorial 12, I will not create all the joints in assembly design as engineering connections. Some of them, which means the roll curve joint, which is not available in motion design, it's called curve tangency. I'm going to do it in that tutorial. All right, folks, good luck. And again, remember, this is not the only way of doing this problem. There are many